Hello friends, welcome to my channel. Today we are going to see how to solve numericals on EMF equation and kVA rating of a transformer. To solve the numericals, we need to remember 5 important equations. Let's see. Okay, first one is magnetic flux density. It's usually represented by Bm. Bm equals to phi m by A. Number 2 is EMF equation of a transformer, that is E1 equals to 4.44 F frequency and one number of turns on primary winding and phi m magnetic flux. E2 equals to 4.44 F N2 phi m. Turns ratio or ratio of transformation, usually represented by letter K, is a ratio of E1 by E2, that is equal to N1 by N2 equal to V1 by V2, and which is equal to I2 by I1. kVA rating of a transformer is a multiplication of voltage per phase, current per phase, multiplied by 10 raised to minus 3, represented in kVA. That is S equals to S1, primary side means V1 I1 multiplied by 10 raised to minus 3, S2 V2 I2 multiplied by 10 raised to minus 3. Load resistance RL is a ratio of V2 by I2. So if we remember these 5 equations, it's very easy to solve the numericals on EMF equations and kVA rating. Let's see how to solve it. Let's see first example. A single core transformer has 100 turns on secondary winding. Secondary voltage is 50 volt at 50 Hz. The cross-section area of a core is 1850 mm square. Calculate maximum flux density in the core. Given data, number of turns on secondary winding N2 100 turns, secondary voltage E2 is 50 volts, area of cross section is 1850 mm square, that is 1850 into 10 raised to minus 6 meter square, frequency 50 Hz. EMF induced in a secondary winding E2 equals to 4.44 F and 2 phi m. Phi m is unknown, so phi m equals to E2 divided by 4.44 F and 2. So phi m equals to 50 divided by 4.44 into 50 into 100. Phi m equals to 0.002252 Weber. Flux density Bm is a ratio of phi m by A. So Bm equals to 1.216 Tesla. So what has been asked? Calculate a maximum flux density in the core. So the answer is 1.216 Tesla. See problem number 2. A single phase 50 Hz transformer has 300 primary turns and 750 secondary turns. The net cross section area of the core is 64 cm square. If the primary induced EMF is 400 volt, find maximum flux in the core, maximum flux density, EMF induced in a secondary. How to solve it? Let's see what is given. Number of turns on primary winding is given, N1 300 turns. Number of turns on secondary winding, N2 750 turns. Primary induced voltage or EMF is E1 equals to 400 volt. Area of cross section is 64 centimeter square, that is 64 into 10 raised to minus 4 meter square. Frequency is 50 Hz. EMF equation of a transformer E1 equals to 4.44 F N1 phi. So phi m is unknown. So phi m equals to E1 divided by 4.44 F N1. So phi m equals to 400 divided by 4.44 50 frequency and N1 number of primary turns, that is 300. So phi m equals to 0.006006 Weber. Flux density is a ratio of phi m by A. So you can easily find Bm, that is equal to 0.9384 Tesla. EMF induced in secondary winding E2 equals to 4.44 F N2 phi m. E2 is unknown and all the terms we already know. So 4.44 F frequency 50, N2 number of turns on secondary winding, and phi m just now we found. So E2 equals to 1000 volt. Let's recap what has been asked. Maximum flux in the core phi m, maximum flux density Bm, and the EMF induced in the secondary E2. A 5 kVA single phase transformer has a turns ratio of 10:1 fed from a 2.5 kV supply. Neglecting losses, determine the full load secondary current, minimum load resistance which can be connected across the secondary winding to give full load kVA, the primary current at full load kVA. Given data. kVA rating is given, that is 5 kVA. Turns ratio is given 10/1. That is N1 by N2 10/1 is equals to V1 by V2. V1 is given, that is 2.5 kV is equal to 2500 volt. So N1 divided by N2 is equal to V1 by V2 is a transformation ratio equals to, so V2 equals to V1 multiplied by N2 by N1. V2 we can easily find because we know the ratio, so V2 equals to 250 volt. As we have studied, kVA rating of a transformer S equals to V1 I1 multiplied by 10 raised to minus 3 equal to V2 I2 multiplied by 10 raised to minus 3. So S equals to V2 I2 multiplied by 10 raised to minus 3. S is given, V2 is given, I2 we can easily find, and that is 20 ampere. Load resistance RL equals to V2 by I2, that is 250 by 20 equals to 12.5 ohm. N1 by N2 equals to I2 by I1, that is our transformation ratio. So I1 equals to I2 multiplied by N2 by N1, that is equal to 20 multiplied by 1 divided by 10. So I1 2 ampere. Let's recap what is asked. The full load secondary current I2 20 ampere, minimum load resistance RL 12.5 ohm, the primary current at full load kVA, that is I1 2 ampere. In this way we have learned how to solve the numericals on kVA rating and EMF equation of a transformer. If you have any questions, please let me know, please comment, and please do like, share and subscribe to my channel. Thank you for watching.